Hello and welcome to the Commerce channel. As I have discussed for a fire case scenario, we should find the lambda in the HYSYS. It could be quite challenging when it comes to the mixture to find the latent heat, because the relief load equals heat that absorbed by a vessel per latent heat. And we should find the minimum value of the latent heat, which result in the maximum value of the relief load. But for a mixture, we have a temperature boiling range, and we should actually find the minimum value of the latent heat. And as you know, latent heat definition is amount of energy that we consume to turn a liquid into the vapor. So within a HYSYS, I will teach you how to find this minimum value of the latent heat. So let's set up our feed stream. So specify the molar composition of each component, whatever your composition or component is, and initially set the pressure, which whatever your receiving pressure is, just specify this value just within a pressure cell. So let's consider we have 10 bar gauge as the relieving pressure. So once you set the pressure, for the mass flow rate, I just specify 1 kg per hour. Doesn't really matter whatever you specify. It doesn't make any changes because I will teach you to how to find the latent heat without just paying attention to this value. So we need to find the initial boiling point, specify vapor fraction into 0, and as you can see, 227.7 is the initial boiling point for our component. So let's switch this into 1, and then you specify the vapor phase fraction into 1. It means that all of your feed turn into the vapor, and its final boiling point is 248.5. So once you find the initial and the final boiling point, just delete this vapor fraction and add the initial boiling point within the temperature. So once you specify temperature, add a heater within the simulation environment and connect this stream into the heater and specify and define an energy stream as well. So once you do that, just add a separator because I want to find how much vapor generated at each increment as I have increasing the energy within this heater. So once you specify initial boiling point, we need to specify the differential pressure. I mean the pressure drop within this equipment. I just specify it into 0, and then again, I just want to run the simulation. As you can see, let me just open up this heater within the worksheet. The feed stream of bond is its initial point is 227.7, and just add 0.1 degree C to this temperature, which is 227.8. So just run your simulation with adding 0.1 degree C to the applet of this heater equipment. So once you specify and run your simulation, you can open up the case study. Let me just open the case study. And within the independent variable, I need to change the temperature with increment of 0.1 degree C and find the mass flow rate of this stream, which is stream 3, and the amount of energy that this heater consumes to turn this stream into the vapor. That's the definition of a latent heat, right? So let me just specify the independent variable, which is the temperature of the stream 2, which is the outlet of the heater. So once you select this independent variable, go to the dependent variable, and within this stream, within this variable at stream 3, which is the vapor that generated, and I want to add the mass flow rate and find the mass flow rate of this stream. This is the mass flow rate of the stream 3. So add this with the dependent variable, and for the heater, just find its this is a heater which is Q100, and find its heat flow. Okay, once you specify and add this independent variable is the temperature, I want to increase 0.1 degrees C at each increment and find the difference, the actually energy difference at each within each increment, and measure how much vapor that generated at each section. So once you do that, just specify initial boiling point, which is 227.7, and the final boiling point is 248.5. So you should add the step size, which as I mentioned, specified at at 0.1 degrees C at each step. Once you specify all this variable, you can run your case. As you can see, the temperature is increasing with increment of 0.1 degrees C at each step, and this row is the mass flow rate of the stream 3, which is the vapor flow. As you can see, that vapor flow is vapor that generated within the vessels. You can see is reported and provided within the table, and the heat flow, which its unit is kilojoule per hour, as you can see within each step, is provided within this table. So I want to send all of this data into the Excel, and just let me define its name, latent heat of mixture. So let me open up what we have actually provided within the HYSYS. As you can see, row B is column B, is temperature. Column C is the mass flow rate of the vapor stream, which means the amount of vapor that generated. And this column is the heat flow, or amount of energy at each increment that heater consumed. So just define a new column with the name of difference of masses. Difference of mass, or the mass difference at each increment. I want to find the difference of mass, and the amount of heat flow, which is the heat flow difference, or energy difference. So once you add this column within actually mass differences, I want to find the amount of the difference between each increment. Okay, just insert equal, and there's a mass difference at each increment is the difference between this cell and the cell above. Okay, once you define this formula, just expand this to make sure that all of this cell are provided within your predefined formula. So do the same for the energy difference, and the energy difference is the difference between this cell and this cell. That means the amount of energy that consumed within the heater. So just let me expand all of this data into the cells. So within this cell, I want to define latent heat, and the latent heat is the amount of difference energy per amount of vapor that generated at every increment. Okay, let's select this cell and hit enter. So this is the latent heat, and its unit is kg per kilogram. You know that. and expand this formula to all of these cells. As you can see, the latent heat at each increment is defined, okay? As you can see, for example, within this case, which temperature is 239 degrees C, 0.2 degrees C, the amount of latent heat is 250. And for example, for this cell, the amount of latent heat at the 241 is 254. And at each increment, we have this value of the latent heat. So let me just delete this value. It doesn't really matter because we haven't defined it properly. And I now want to find the minimum value of this, this cell, and type the minimum function within the Excel and select the first cell, which is G5. G5 is the first cell, and the final cell that we need to specify to find the minimum value of these numbers is G212. And let me just, add G5, and G212 is the last value within this column. So just hit enter. As you can see, this is the minimum value of the latent heat of mixture. This is a minimum value of the latent heat for the mixture of C5 to up to C10 at 10 bar gauge. As you notice, we should find the minimum latent heat to put it within this correlation, which consequently we can find the maximum value of the relief load. I hope you found this tutorial helpful. Have a good time. Take care. Have a good time. Bye.